Hello everyone, this is Kitish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier from 2018. Question number 2 is on the topic of atomic structure to do with radiation or nuclear radiation. A teacher used a Geiger-Müller tube and a counter to measure the number of counts in 60 seconds for a radioactive rock. So they're counting for 60 seconds. The counter recorded 819 counts in 60 seconds. The background radiation count rate was 0.3 counts per second. Calculate the count rate of the rock. So the count rate is going to be 819 divided by 60. As you can see, the answer they want is in per second. So if I divide 819 by 60, let's bring in the calculator. 819 divided by 60, that gives me 13.65. 13.65. Now that's including the background radiation, so I need to take away the background radiation from this value. So minus 0.30, take away 0.3, and that gives me 13.35 per second. So that's 13.35 per second. Question 2.2. A householder is worried about the radiation emitted by the granite workshop in his kitchen. 1 kilogram of granite, so 1 kilogram of granite has an activity of 1250 becquerels. The kitchen workshop has a mass of 180 kilograms. Calculate the activity of the kitchen worktop in becquerels. So if 1 kilogram has 1250, then 180 kilograms would, you simply multiply those two values. So 1250 multiplied by 180 should give me 225,000 becquerels. 225,000 becquerels. Next question. The average total radiation dose per year in the UK is 2 millisieverts. Table 1 shows the effect of radiation dose on the human body. Radiation dose in millisieverts, if it's 10,000, it's immediate illness, death within a few weeks. 1,000 millisieverts would be radiation sickness, unlikely to cause death, and 100 millisieverts is the lowest dose with evidence of causing cancer. The average radiation dose from the granite worktop is 0.003 millisieverts per day. Explain why the housekeeper should not be concerned about his yearly radiation dose from the granite workshop. 1 year is 365 days. So if they are receiving 0.003 millisieverts per day, what will be the total radiation received in a year? So if I multiply 0.003 times 365, that would give me 1.095. That's the yearly dose that they would receive from the granite worktop. That value is much less than 100 millisieverts, right? That would actually cause cancer. So 1.095 millisieverts is far lower than, which is 100, the dose, DOSE, that would cause cancer. Next question. Bananas are a source of background radiation. Some people think that the unit of radiation dose should be changed from millisieverts to banana equivalent dose. Suggest one reason why the banana equivalent dose may help the public be more aware of radiation risk. Now, bananas are consumed quite often, so if I can compare the amount of radiation received to the number of bananas, then people will be much more easier to understand. So for example, when I say for the above, right, what does 1.09 millisieverts actually mean, and what does 100 millisieverts mean? Let's say 1 millisievert is equal to 1 banana, radiation from 1 banana, right? So no one actually consumes about 100 bananas a day, right? So in that way, you could actually compare it much easily. So the answer, people are able to compare a radiation risk or dose or hazard to the radiation dose from eating bananas. That brings us to the end of question number 2. I will see you in the next video.